All right, so I'll kick this off. So I'm Katherine Scott. I'm the developer advocate over at Intrinsic. I'm also the developer advocate for the OSRA. I'm here to talk about ROS, or Robot Operating System, and how it's transforming manufacturing and just about everything else. So who's used ROS here? We should get more hands. Interactive? Yes? Okay, good, good. Hopefully there's a few people. So what is ROS? So ROS, when you say ROS, R-O-S, it stands for Robot Operating System. I would claim that it is most likely the largest, most commonly used robot development framework on planet Earth, and it's free and open source software. We also have a companion program for ROS called Gazebo, which is a robot simulator. So if you don't want to actually be on the floor working with your robot, you want to be at your comfy desk doing robotics development, that's what it is. People always say, that can't be the case. ROS can't be that big. So since ROS is open source, we don't track people. The ROS doesn't phone home when you install it and say, oh, this person installed ROS. We maintain our own internal list of ROS users. I can tell you as of last year, I think it was close to 1,600 people. And we only know those 1,600 people because I've had conversations with them here at Automate, or they've asked us to help them finding people that use ROS as developers. And that number, I think, grew, what did we grow at, 26% last year? And just to give you a flavor of this, I was at ICRA, the big academic robotics conference, 2 weeks ago. Kamau was touting their support of the ROS developer ecosystem. Shunk was handing out flyers that had, all of their grippers with 20% and 20% off, and they're like, oh, look, these all run ROS now. Our neighbors over there, Fanuc, are very happy to report that all of their robots now support ROS. And if you want more names and more companies, our colleagues over at ROS Industrial have a full industrial consortium. And these are all ROS users. I know most of these are probably too small to see, but if you want to learn more and learn about what they're doing with ROS, they have a booth that way. If you use the app, it's actually listed under Southwest Research Institute because they're part of a larger organization. We also have colleagues over at Picnic, which is on the other side of the expo hall here. They have a full website that lists every major robot vendor and their ROS support, along with a bunch of cameras, a bunch of other sensors, AMRs, drone controllers, a bunch of other stuff. And you can actually check how a particular component or OEM is supporting ROS and where to find the drivers. In terms of people or software downloads, I can tell you that last year we just came in at just shy of 1 billion ROS packages downloaded, which was, I think, close to 80% increase year over year. I pulled those, I think we pulled these numbers in January. I just pulled them for May. We're on track to hit close to 2 billion ROS package downloads this year. On the people front, if you don't believe those are downloads, I can tell you that we have a big conference every year. Last year was in Singapore. There was about 1,000 ROS developers there. And then we also do regional ROS conferences in countries like Croatia, Japan, Korea, India, China, France, Germany, Spain. And this year, I think we're also doing Turkey. I think that's most of them. The other one is academic. People often say, oh, ROS, this is an academic enterprise. And largely when it started, it was the original ROS paper has coming up on 15,000 citations. And people tend to think of the ROS as this academic thing, and maybe it was. But another way to think about it is it's sort of building your labor force for the future of robotics. So over at ICRA, I got to sit around as hundreds of students were racing autonomous RC cars around the pavilion, just hundreds of students learning ROS, building their first robot. And that's all done using ROS via another package called AutoWare. And what I think is interesting is some of these students eventually go on to go do things like build full-size Indy cars down in Indianapolis and race them autonomously. So if you think ROS may not be ready for your application, actually it probably is, because it's running on cars going 240 miles an hour. All right, so the key take-home I want you guys to remember is ROS is basically to robotics what Linux is to the internet at this point. It is the thing that lets you build, it is the open source software that lets you build the things you want to build. Intrinsic supports ROS in a huge way. So back in January of 2023, Intrinsic acquired the for-profit arm of an organization called Open Robotics. Open Robotics is the nonprofit that basically stewards the ROS project. On a going forward basis, Intrinsic is basically continuing to support ROS and is working with ROS developers to clear up some of the hurdles they may still have. When you think about ROS, I tend to break it into two parts, right? There's the software, the development part of it, the code, and then there's the community part. And I'm going to talk about the code and infrastructure part first. So what is ROS? It's basically three parts. It's the core code, so it's the basically software API and software primitives that are used to build ROS applications. And then there's this huge package ecosystem of things like OEM vendor drivers, of software modules that do stuff like path planning or inverse kinematics. And then it's the tooling. ROS has a ton of tooling to do stuff like data collection, debugging, logging, simulation, visualization, all those kind of things. ROS has this sort of Linux-like development philosophy. And so there are quite a few things in here, but the first one I think is important is we're really trying to work in a federated manner versus a centralized manner. And right now in software engineering, I think there's sort of a move towards centralization, and we actually have moved a lot away from that. Meaning that people all over the globe are developing the things they need to develop for the ROS ecosystem, and we all kind of come together and do what we need to do. Generally, ROS programs are composed of smaller, simpler, reusable components, all pushed together into a final application, much like a Unix system is. We try to be developer friendly, so we try to include all the things you need in a particular package, the documentation, the messages. And we prefer people not reinvent the wheel. Usually when a new subdomain in robotics pops up, we get 2 or 3 different implementations of it, and the community standardizes on one piece of software, and then iterates and improves that piece of software, and it becomes the shared global tool. We're also non-exclusive in the sense that you're not tied into using something like C++ or Python or Rust. You can use any of those languages to develop your ROS application. I also like to think of ROS as inclusive. A common discussion I have is people say, oh, I can either use ROS or I can use something else. And the reality is you can use ROS with that something else. So like if you look at Boston Dynamics across the street over there, they use ROS. They don't use it for the control systems on, say, Spot, but they do use ROS at the API layer for their end users to have a friendly user interface for their customers. And then the last one is ROS is generally about freedom. So we prefer to have BSD, sort of business and development friendly open source licenses. At the end of the day, ROS is very open and modular. So at its core, we've basically built a common standard library for building different parts of a robot. Think things like message passing, blackboards, multi-process programming, that kind of thing, how you start the robot. And then we add on top of it this entire ecosystem of packages, everything from a piece of hardware to pure software plays. Then we add on top of all of that tooling. So we have tools so you can do visualization. You can see what your robot's doing, what it's thinking. You can debug it. You can do your planning. You can do your decision trees, all of those sorts of things. Safety and security is another big part. Because we're open source, as changes evolve in the software ecosystem, we can compile them very quickly and then push them out. So it's not like something is sitting, getting buggy over time. And then finally, ROS is extremely flexible. It can be recompiled for just about any platform you'd like to use it on. I've seen ROS run on everything from embedded microcontrollers effectively to giant server racks trying to process, say, I don't know, 10 cameras concurrently in real time. So we all know robots do 3 things. Generally, they sense, they pull a bunch of data from the environment, whether it's a camera, force feedback controller, LiDAR, radar. They think about that data, they process it, they push it through some algorithms, and then they act. You send it either to some wheels or to a robot arm or to a servo. And the way this all kind of works in ROS is that you have what we call a ROS node. When I say node, just think of program. So you have a node that does one thing, probably connects to your sensors. Then you have some sort of node that's doing the processing, the thinking about the data that just came in. And then that data goes to some sort of other ROS node that handles the actuator or the control of something. And moving data between all of this, we usually have what we call a ROS middleware layer, which is just a way of moving data between all of these things quickly and effectively using standard messages. And those nodes end up taking the form generally as parts of ROS packages. So if you go to, say, index.ros.org, you could look up packages for things like universal robot arms or KUKA robot arms or SICK laser sensors or Ouster laser sensors or Intel RealSense cameras. All of those are available on index.ros.org. On the software side, we have stuff like nav2, which does control for mobile robots, say AMRs. We have stuff for state machines, packages for forward and inverse kinematics, even packages that run like single platform hardware robot. Adding to that, we have some really great ROS tooling. You start with tools that help you, since you have this complex software environment where you have multiple languages, you have tools that help you build everything and smush it together into a final program. You have, and actually then start running it. So you can compose all your programs into a single script. You say run that script and it launches all these programs with all the parameterization that you need and your robot starts up. We have some great tools for data collection and data sharing. It's called a ROS bag. So we basically have an open data format that shoves all of the data that can be in your ROS system at any given time into a file that can then be shared, run, and rerun by anyone out there. And then finally, we have some great user interface tools, and we have a great, like, sort of evolving user interface ecosystem. So ROS immediately ships with a tool called RViz, so you can see the state of your robot and any sensor data on it at any time. But you can also use tools like Foxglove or Rerun or tons of new, interesting vibe-coded apps that just got made. So ROS is constantly evolving. It's constantly being updated. At this point, we've released 2 major versions, ROS 1 and ROS 2. ROS 1 is no longer being supported. ROS 2 is the latest and greatest. And we've done 26 releases over those 2 major versions. Every year, particularly every even year, we do a major ROS release. So about, I think, exactly a month from today, we released Lyrical Luth. It's our latest long-term ROS 2 release. It will be supported until May 2025. There's a couple big things in there. I'm not going to bore you with a ton of software details. This looks really boring. It's ROS IDL buffer. The quick answer here is we worked with NVIDIA to build a new data format inside of ROS that lets you move data very, very quickly with zero copy operations from, say, something like a camera or a LiDAR sensor directly into your GPU, do some computer vision or machine learning or deep learning magic on that GPU, and then move it out of the data or out of the GPU somewhere else without doing any copy operations, which means it goes really, really quick. Another big one, this is a very short list of a very, very long list of new features. We added async Python support. Generally, Python's not a great sort of parallel programming modality, but it is something that's very easy for people to use and think about. So we just added a new async IO event loop. This lets your programmers work very, very quickly to build robust applications dealing with lots of different data streams. All right, let's talk about the community side of ROS. ROS, kind of like Python, derives a lot of its power from having a very, very large distributed open source community. Upstream of ROS, we have basically the whole Unix and Linux open source communities, right? So we can leverage all of their cool open source tools that have been used for 10, 20 years that are extremely robust and power the web servers that you use every day. And then downstream of ROS, we have all these package developers that are building new interfaces to new forms of hardware, new software libraries, that kind of thing. And this means that ROS ends up being part of this larger open source ecosystem. So on a day-to-day basis, I'm talking with people at Drone Code who build open source drone controllers, colleagues at Nav2 who basically built the navigation software that runs on most of the AMRs you're going to see here today. Our friends over at OpenCV are constantly working to fix computer vision problems that people run into with ROS. They just did a major 5.0 release that has a ton of optimizations baked into it. And we have a ton of other partners. I will mention Ubuntu's just done some great work. They have a new product called Workshops that's kind of like a Docker container without the Docker container compute overhead. Very cool stuff. Another part of the community is our sort of sister project, Gazebo. You can see examples of Gazebo over in this little hallway. Basically, Gazebo is a highly configurable robot simulator. Some people call it a digital twin. You can call it a video game on steroids. But really what it is, it's a way to visualize your robot, put your robot in a simulated environment and run it, and do so without the robot in front of you. It's been tried and true. It's over 20 years old. We've worked with NIST to do a bunch of manufacturing competitions with it. We've worked with DARPA to simulate caves and other things. You can try it out, and it's fairly robust, and there's a whole ecosystem of assets that you can just drag and drop into Gazebo. If you're really interested in this worldwide developer community, we have a global developer conference that happens once a year. It's actually happening in Toronto, which is drivable from here. That's happening on September 22nd through the 24th in Toronto. I hear Intrinsic's got big news for that conference. Or if you just want to go online and check out a few things right now, we have a ton of resources that you can just go read through. If you want to see what kind of ROS packages are available, they're all at index.ros.org. If you want to chat with our core developers, they're over on zulip.ros.org. Documentation all lives at docs.ros.org. And then we also have a discussion forum where people talk about the latest and greatest ROS developments at discourse.ros.org. Or you can just look at our source code. It's up on GitHub. So if you still have questions, I'm around, Tully's around, my colleague Tully's around, or he was around. He's kind of around. We're more than happy to answer your questions if you have any. Thank you.